So choline is one of those molecules that when fed as choline chloride or choline that's present in feeds, the rumen microbes tend to destroy that almost completely. So more than 90% of the choline in dietary ingredients, or if we supplement as choline chloride, gets destroyed in the rumen and converted to these trimethylamine products.
Hello everyone, this is Luis Ferreiro with the Dairy Nutrition Blackbelt Podcast, and today we will continue our discussion about choline. To continue this discussion with us, we have Dr. José Santos from University of Florida joining us again. José, thank you so much for joining us again to continue this discussion. I'm sure people at home is thrilled to learn more about this topic, which is obviously a very key topic, especially for transition cows. So said that, I would like to start with our questions here. Obviously, whenever we see commercial products for dairy cows particularly, those are rumen protected. So tell us more about why does choline have to be rumen protected, and how do we measure bioavailability to make sure that those are truly rumen protected?
Those are really excellent points. But all choline products are based on salts of chloride. Yeah, so choline chloride is the basic molecule that's used to supplement choline. In the case of ruminants, unfortunately, as much as the rumen helps us with many things in digestion, it deters us or the cow from getting things that would otherwise be quite easy to supplement in monogastrics like pigs and poultry or even baby calves. So choline is one of those molecules that when fed as choline chloride or choline that's present in feeds, the rumen microbes tend to destroy that almost completely. So more than 90% of the choline in dietary ingredients, or if we supplement as choline chloride, gets destroyed in the rumen and converted to these trimethylamine products. Actually, these trimethylamine products get absorbed, and there is an enzyme in the liver that converts into this trimethylamine oxides that now the medical literature is involving this molecule as part of risk factors for coronary heart disease. We'll see if that's really a causal relationship or just another association. But anyways, work that was done in the early 80s with sheep using radio-labeled choline showed that almost all the choline that was present in the diet was destroyed, and the choline that was present in tissues of the sheep were synthesized by recycling choline molecules in the body. And then Rich Erdman, who used to be at University of Maryland, did probably the foundation work showing that if we feed choline unprotected to cows as choline chloride, less than 7% of that shows up in the small intestine. So that created the need to develop rumen-protected products, exactly the same concept as feeding rumen-protected amino acids and other things. Yeah? So this is why the industry has developed multiple products. Different companies have different products out there, and they usually use some method of encapsulation with saturated fatty acid compounds to limit microbial access to that. Obviously, every time you protect something, you want to be sure that you have extensive protection against microbial degradation, but at the same time make it available to the cow once passed through the rumen and it gets to the abomasum and the small intestine. To my knowledge, we don't have a really good method of assessing bioavailability. I think every company has quality control systems in place to determine whether their encapsulation method prevents microbial degradation, which you can do in vitro, in situ, in animals. The issue is to answer your question, how much of that is bioavailable? And it all depends on what we define or how we define bioavailability. So if we think about drugs and from the pharmacokinetics point of view, bioavailability is of what I feed in this particular case, how much shows up in blood, in the bloodstream of the animal. And choline is a tricky compound because once absorbed in the small intestine, it may be taken up by the local tissues in that first pass, and it may be converted to phospholipids right there or sphingolipids. There's plenty of narrow tissue in the intestine that may take that up. So if you look at the literature on bioavailability, true bioavailability of choline, there's only one paper that I'm aware of by Mike DeVet. It was published in the Journal of Dairy Science in 2016. And what they did is they used multi-catheterized cows. So these dairy cows, they teamed up with a group in Canada, Eline Lapierre, and they assigned cows to, if I recall correctly, I think 5 treatments. They had a negative control. Then they had 2 doses of choline ion, which was infused either in the rumen or in the small intestine. In the rumen, they dose as Rumen-Protected Choline. So in the dose of choline ion were something like almost 13 grams of choline ion, 12.9 or 25.8. They doubled the amount. And they fed that as rumen-protected choline, but they dosed that through rumen cannula directly into the rumen of those cows. These cows had catheters that were placed in the portal vein, the mesenteric vein and artery, and in the hepatic vein. And they use a dye to measure blood flow across the splanchnic bed. And the data they report, they looked at the net fluxes of choline when they place choline as Rumen-Protected Choline in the rumen, or they infuse into the abomasum choline chloride. So the choline chloride that was unprotected was infused directly into the abomasum. And that was, quote unquote, the gold standard to say, hey, we bypass the rumen. Let's look at the net fluxes in the portal vein or in the hepatic vein. And then they fed the same amount, but in a rumen-protected form. So in that particular study, when they dosed the rumen and they pulled together both doses and they compared with the appearance of choline molecules in the portal drain viscera, the relative bioavailability of choline as rumen-protected choline was something like 14%. So when they infused choline chloride bypassing the rumen, which they truly did because they infused directly in the abomasum, a certain amount of that choline showed up in the portal vein, and it showed up as choline ion, multiple phosphatidylcholines, betaine, so different products that showed up in blood. So they look at how much of the same products showed up as when fed as rumen-protected choline. And for the choline ion, the amount that appeared was approximately 14% of the amount that appeared when they infused choline chloride in the abomasum. So this tells me that either the protection is not 100%, which I don't think it is, of any product, but also the intestinal availability is not as high potentially as feeding the original product bypassing the rumen. So I'm sure every company knows the limitations of a rumen-protected product. They are not perfectly protected, and they are not 100% available once they escape the rumen. So there's that combination of factors that need to be studied. And I'm not sure if we have a very objective system, because these are pretty labor-intensive experiments. I'm not sure if companies, I'm sure they have their own internal system that tells them, hey, we have a good product to put in the market, because those products obviously work. But if you were to ask me, of the 10 or 15 or 20 grams of choline ion, how much the cow absorbs, I don't think we really know that, Luis.
Looking to maximize your herd's potential? Elevate performance with Kemin's cutting-edge encapsulation technologies, including Rumen-Protected Choline, methionine, and lysine. Kemin's advanced choline and amino acid technologies ensure precise nutrient delivery, boosting milk yield and enhancing herd health. Trust Kemin, the experts in encapsulation, to take your herd to the next level. Learn more today at kemin.com/dairy.
No, absolutely. And certainly will be very difficult to continue to run those studies, because it's not only labor intensive, but are probably very expensive. It's very complex from a cow perspective too, because you probably require a lot from the cow. So definitely is the type of trial that we cannot keep repeating over and over just to estimate product bioavailability. I agree 100% with your assessment. So Jose, obviously you mentioned a couple of those different doses, right, that were tested for that bioavailability study. Said that's probably a question that we went as nutritionists and dairy farmers about what is the ideal rate that they could be feeding about choline. So what are your thoughts about the minimum and maximum rates to get the best effects? And by best effects here, I'm thinking about energy-corrected milk or energy-corrected milk efficiency, as those were some of the nice results that you mentioned that you obtained when you were running your meta-analysis a few years ago.
So, Luis, when we search literature, in every experiment that we look into, there was always obviously a negative control. So cows that were not fed any rumen-protected choline. And then the range of supplementation went on from approximately 5 to 26 grams of choline ion fed as choline chloride that was rumen-protected. So choline chloride is about 75% choline ion. The other 25% is the chlorine in the molecule. So when we investigated that, so we tested whether the relationship between choline feeding and energy correct milk was either linear or quadratic. Yeah. So whether it was a constant rate of change, or if we would detect a plateau. We really didn't find a quadratic relationship between the amount of choline ion supplemented and the response in terms of either milk or energy correct milk or feed efficiency, energy correct milk per kilogram of dry matter intake. So our conclusion from that particular meta-analysis was that the response was linear up to almost 26 grams of choline ion, which is about 35 grams of choline chloride. Okay, so there is a recent meta-analysis published in the Journal of Dairy Science that I mentioned earlier that also looked at that. And the way they did, they found an optimum, what they call an optimum amount of choline chloride supplemented for different responses that they measure. So if you go there, that amount, if I recall correctly, it's close to 21 or 22 grams of choline chloride, which is about 15 grams of choline ion, something like that. Okay. One of the issues is that most of the experiments that have been done with Rumen-Protected Choline, they have used a single dose. So the bulk of literature is in this about 13 grams of choline ion, which is about 16 to 17 grams of choline chloride, maybe a little more. Yeah, maybe 17 grams of choline chloride. So that puts a lot of power in that level of supplementation. But when you look at the edges, let's say at the extremes, there's not a lot of experiments that fed 25 or 28 grams or 30 grams of choline ion to cows. Neither are many that fed only 5 or 6 grams. So the statistical power to look at the extremes becomes a lot weaker compared to what's in the middle of the data set, in which probably 75% of experiments use the exact same dose there. So if you ask me personally, I think the industry has moved to this standard dose just because that's what technical service within companies recommend based on the experiments they've done, this 12, 13 grams of choline ion in a rumen-protected form. But I believe that the response is present at a larger dose. Okay, so there are data in literature with mid-lactation cows that have been fed even very, very large dose, 35, 40 grams of choline ion, and they showed increments in milk yield. Now, we've done experiments looking at a different type of response, which is fatty liver, reduction in concentration of triacylglycerol in the liver. And we've shown in 2 experiments. In the first, we had 77 cows that we induced fatty liver. In the second one, we had 110 cows that we induced fatty liver. And the response was linear up to almost 26 grams of choline ion. So using this model of inducing fatty liver, supplemental choline reduces the degree of steatosis at a much larger dose that typically fed to lactating cows during the transition period. So my gut feeling tells me that a larger dose is more beneficial, but then it gets into this cost-benefit question, because it will cost more to feed more. But it's unquestionable that the dose at about 12 to 13 grams of choline ion has been very effective at stimulating energy-correcting milk yield.
No, absolutely. And obviously what I'm going to say next here is probably a dangerous area, but based on what you said, it probably makes sense to suggest a higher dose for those herds that actually have a huge amount of issues with transition cows, especially fatty liver, because it may help them to solve the issue a little bit faster until they can transition to a dose that you call maybe better for ROI and something like that. So certainly I think this is a great input because probably there is a lot more to learn there. José said that. Do you have any final considerations about choline in general or the use of choline for dairy cows?
I'll make 2 final comments. One is that choline is an interesting nutrient because although it's not essential from the perspective that if we don't feed, cows won't die of choline deficiency. It's not like if we were to feed no calcium at all, cow would develop issues, or feed no amino acids and prevent microbes from synthesizing essential amino acids. You would have issues with essential amino acid deficiency. But that's not the case of choline because there is endogenous recycling. But it's interesting that to the best of my knowledge, and I talk to people who spend their lives studying choline in biochemistry department, there is no described pathway for endogenous synthesis of choline itself. There's endogenous pathways for synthesis of the phospholipids and the sphingolipids, the numerous phosphatidylcholines, the numerous lysophosphatidylcholines or sphingomyelins, but not for choline itself. So I think choline should be part of a required nutrient, at least in this transition period. At some point, I think the scientific community will recognize that. Maybe now it's early, but maybe in a new event of a NASEN or another guideline recommendations that will be present there. So that's one of them. And the second one is that there is this ongoing, because choline interact with other nutrients, and one that's well known is methionine. Okay? So methionine not only is a precursor for protein synthesis as essential amino acids, or an essential amino acid, but methionine is a methyl donor, and there is a relationship in the biochemical pathway between transferring methyl groups and synthesizing phosphatidylcholines. But there's this argument in the industry, which I find a little odd and foolish, that, hey, if I feed this, I don't need that, or if I feed that, I don't need this. And although there is a relationship between the two, one doesn't replace the other. So if we feed choline, we don't necessarily increase milk protein content. We may increase yield of milk protein because it stimulates milk production. But at the same time, if we feed methionine, we don't necessarily enhance the ability of the liver to export triacylglycerol and prevent fatty liver. And there's plenty of literature on that, showing that methionine is really important, has lots of roles, and it's very beneficial, particularly in early lactation, to the typical U.S. dairy cattle diet. But it doesn't necessarily replace choline, and choline doesn't replace methionine. So I would wish the industry stop arguing about these two things and would see this as complementary nutrients and not necessarily one competing with the other.
No, absolutely. I highly agree, and think there is a space for a lot of different nutrients, right, if you will, to be added to diets to make sure that we optimize the cow and not necessarily anything else. So, José, thank you again for joining us today. I'm sure people will be delighted to learn about the history of choline and everything associated with that. Thank you at home for joining us today, and I hope to see you soon.
Thank you, Luis.